Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera. My name Nur Ain Bazilah binti Mazlan, AA 250708. Today, I want to present introduction and project background. First, this project focus on capturing carbon dioxide or CO2 from industrial flue gas. CO2 is a major greenhouse gas that contributes to global warming and climate change. We use MEA absorption technology to recover, purify, compress, and liquefy the CO2. The liquid CO2 can then be used in the food and beverage industry, fire suppression system, dry ice production, and chemical manufacturing. Overall, this project helps reduce carbon emissions and support sustainable engineering technology. Thank you. Next, I will explain our project objective. First, to recover and purify CO2 from industrial flue gas so that it meets industrial quality standards. Second, to compress the captured CO2 and convert it into liquid form for safe storage and industrial application. Finally, to develop a sustainable carbon capture process that reduces greenhouse gas emissions while producing valuable liquid CO2 for the food and beverage industry, fire suppression system, and chemical manufacturing. Thank you. These slides explain the environmental importance of CO2 recovery. Industrial flue gas from power plants, cement factories, and chemical industry is a major source of CO2 emissions. By capturing CO2 before it is released into the atmosphere, we can reduce greenhouse gas emission and help slow down climate change. In addition, the recovered CO2 can be reused in different industries, supporting a circular economy and making industry processes more sustainable. Overall, CO2 recovery helps protect the environment while creating valuable industrial products. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hakam Syairi. So now I will present about our block flow diagram for our projects. So our BFD has 5 main stages, which is first one is industrial flue gas, number 2 is carbon dioxide capture, number 2 is CO2 purification, number 4 is CO2 compression, and number 5 is liquefaction and storage. So for the industrial flue gas, they have raw feed containing carbon dioxide, nitrogen, and also oxygen, and also water vapor and particulates from industrial sources. Number 2, in the carbon dioxide capture, we have MEA absorption column removes carbon dioxide from flue gas to clean exhaust gas is released. Number 3 is carbon dioxide purification, which is moisture and impurities removed to meet industrial quality standards. Number 4 is carbon dioxide compression, which is pressure increased to prepare carbon dioxide for efficient liquefaction. Number 5 is liquefaction and storage, to compress carbon dioxide to cool to liquid form and stored in product tank for distribution. Okay, so now for the BFD stage descriptions. So our BFD have some stages. So the first one is industrial flue gas, the feed. So the raw feed stream containing carbon dioxide, nitrogen, oxygen, water vapor, and particulates from industrial combustion sources. So basically our project ni untuk asingkan gas asap-asap yang terbuang daripada kilang, which is flue gas tu. Dia kita akan asingkan, kita akan tapis, kita akan rawat untuk asingkan carbon dioxide dia, untuk kita rawat supaya lebih sihat untuk dilepaskan, lebih selamat. So for the next stage is carbon dioxide capture, MEA absorption. MEA solvent selectively absorbs carbon dioxide from flue gas in the absorber column to release clean exhaust gas ke atmosphere. So for the next stage is carbon dioxide purification. moisture and residual impurities are removed by condenser and gas dryer to meet industrial purity standards and untuk prevent equipment corrosion. So kat sini dekat purification ni gas sebelum dibuang tu akan dirawat supaya lebih selamat lah untuk dilepaskan, dan also selamat untuk any equipment dekat industri. Next, the next stage is carbon dioxide compression. The purified gas carbon dioxide tadi yang dah dirawat akan dikompres dalam multi-stage compressor with aftercooler, preparing it for efficient liquefaction. Sebab dekat sini gas ni akan dikompres, senang cerita macam akan disejukkan supaya lebih efficient tau untuk next stage nanti, which is carbon dioxide liquefaction. So compressed carbon dioxide ni yang dah disejukkan dekat liquefier unit akan convert phase dia. Maksudnya from gas phase to liquid form supaya dia lagi suitable untuk masuk ke dalam storage tank, which is our it is the final stage. Okay, so for the final stage is liquid carbon dioxide storage. The final liquid carbon dioxide product is held in a pressurized storage tank before distribution to end use industry. Maksudnya lepas dah jadi liquid dalam bentuk liquid form, liquid carbon dioxide tadi akan dimasukkan dalam storage tank untuk kegunaan industri macam food beverage, fire extinguisher, chemical manufacturing and also dry ice. So next I will present about our process flow diagram, which is our PFD for our project. So our PFD is drawn by AutoCAD and drawn by me also, and the AutoCAD to develop PFD illustrating all major process systems and unit operations. So first, in our PFD we have bed filter, which is from the industrial flue gas. The raw flue gas will through into the bed filter for the first major equipment. After that, all the gases through the bed filter, after the filterization is complete, all the gas will into the gas cooler and to the blower and absorber column. Next stage, all the gas will through into the rich solvent pump, heat exchanger and stripper column, and then all the gases will into the reboiler, condenser, gas dryer and also carbon dioxide compressor. After that, all the gases will through into the aftercooler, liquefier, and final all the product, the final liquid carbon dioxide will into the liquid carbon dioxide storage tank. All the standard instrument symbols we don't draw the PFD using the symbols because I think for the last semester that we learn is our PFD doesn't have any symbols except our PNID. So I didn't draw any symbols in our PFD. Okay, now for the major equipment and their functions is the first one is bed filter. The functions is to remove particulates from raw flue gas before processing into the gas cooler. Okay, so the next major equipment is gas cooler, and the functions is to reduce flue gas temperature for optimal MEA absorption. And the next equipment is blower. After all the gas into the blower will transport flue gas through the absorption system, and in the absorbers column they will capture carbon dioxide from flue gas using MEA solvent. And the next stage is rich solvent pump. It will transfer carbon dioxide laden MEA to the stripper. So the next major equipment is heat exchanger to recover thermal energy between rich and lean MEA streams. So next major equipment is triple column and reboiler, which is to regenerate MEA solvent by releasing absorbed carbon dioxide. And next major equipment is condenser and gas dryer to remove moisture from carbon dioxide stream for purity. After that, the next major equipment is carbon dioxide compressor and aftercooler. The function is to increase carbon dioxide pressure and control temperature for liquefaction. And after that, all the gas will into the liquefier to cool compressed carbon dioxide gas to convert it into liquid form. For the final is all the product will into the storage tank, which is to store final liquid carbon dioxide product before distribution. Thank you.
This slide shows stream process in the CO2 capture system. First, CO2 is filtered and cooled. Next, CO2 absorbed by the MEA solution in the absorber. Then, CO2 is released in the stripper. Finally, CO2 dry compressed, liquefied and stored, while MEA solution is recycled for reuse. Explain purification, compression and liquefaction process. First, moisture and impurities are removed by the condenser and gas dryer to produce high purity CO2. Then, CO2 is compressed to require pressure. Then, CO2 is cooled and liquefied to easy storage and transportation. Finally, heat integration help improve the overall energy efficiency of the process. This slide explains industry application and sustainability benefit proposed in the system. By capturing liquid CO2 be used in the food beverage industry, fire suppression system, dry ice product, chemical manufacturing. By capturing CO2 before it released to the atmosphere, it helps reduce gas emission. In addition, it supports circular economy by converting waste CO2 into valuable product and benefiting both industry and the environment. In conclusion, this project was successfully designed a CO2 recovery liquefaction process from industrial flue gas. The process helped reduce greenhouse gas emission by converting CO2 into valuable product. Overall, it is practical and sustainable solution for carbon capture and utilization. Thank you.